Hello, I'm Casey Bortmus from ASU, and this is my FSE 100 Deliverable 4 project video. Here is the simulation for my robot, Dexterity Bot, a mechanical arm on wheels. First, over here, we have the main body circuitry, two wheels, front wheel drive, left and right, and then a sensor on the front and a sensor on the back. When this sensor senses an object close both at the front and at the back, it'll consider itself stuck and stop moving. It'll also turn on this LED, which symbolizes it alerting BuddyBot to come help it and let it know that it can't navigate. If we have object farther away from the back and close to the front, it'll start turning left because that'll mean that it sees an obstacle in the front. So it'll turn left until there is no obstacle. When the front way is clear, it'll then move forward. These two motors connected through an L293D pin, which are connected to the Arduino. Up here, we have the arm circuitry, a sensor, and a servo motor. Realistically, a mechanical arm would have a lot more than just one servo motor, but for simplicity, I've condensed it down to one. This sensor senses the distance to an object inside of the arm, and if it detects an object nearby, and that is within 20 centimeters, it'll say that there's an object nearby by activating this yellow LED, which is connected to the Arduino. If there's not an object nearby, it'll signify the green LED to turn on. The servo motor also changes based on whether or not something is detected from a couple of different angles, just to show that it's detecting an object. In the code here, we have the serial monitor, which shows us all of the distances over time from all different sensors, the front one, the back one, and the arm one. Here is the full code. That's the code. The way it works is that we have all of our variables, the triggers and the echoes for the sensors, for each of them, the servo stuff, object near, object far, servo signal. We set up the servo and attach it. We have the pin modes here. Most of them are output. We got a couple of inputs, mainly in the echoes. This is the code for the serial monitor and what it outputs. And these are the various functions that I use to get the distance, which are down here. And they get the distance for each sensor. This is the code for the arm. So if the sensor detects something less than 20 centimeters ahead, it'll go to 90 degrees and activate that LED. If it's greater than or equal to 20 centimeters, it'll go to the other angle and activate the other LED. I don't think that. There we go. That's the near one. And then the motion algorithm, greater than 50 centimeters, it'll just move forward. Less than it will turn left. If there's something close to the back, less than 25 centimeters, it's set to just move forward to get away from that. But then, if both of them are too close, it will stop moving. There we go. It'll stop moving. So yeah, that is my robot. Thank you so much for watching my presentation.